In this video, we'll be using the degree and leading coefficient of a polynomial in order to describe the beginning and end behavior of that polynomial on a graph. So what's really cool about polynomials is there are actually some very consistent end behavior patterns that occur related to the degree of the polynomial. So there are two specific cases that are going to occur. The first is that we have a polynomial with a degree that is odd. So that's something where the highest degree is odd. So you're thinking x to the 5th, or x to the 7th, or x to the 29th. The highest degree in that polynomial is odd. And when that happens, the beginning of the graph and the end of that graph have opposite behavior. So what I mean by that is that if the end of the graph is going up, so for example, say the end of this graph is going up as x continues to get bigger, then the beginning of this graph would have been going down. And there's going to be some movement in the middle here, but what we know is that one end is going up and one end is going down. The other option that can happen is if the end behavior is going down, then the beginning behavior has to be going up. And again, there's going to be some stuff that happens in the middle here. But if the degree is odd, the two ends are going to be going in opposite direction. One is going to be going up and one is going to be going down. So you can automatically assume, regardless of what's going on the inside, that the end behavior, or what's going on forever to the right and forever to the left of this graph, is going to be two different things. Then from here, if we have a highest degree that is even, what's really cool about these graphs is that the end behaviors, so what's happening going forever to the right and forever to the left, is always going to be the same. So where odd functions result in one end going up and one end going down, in an even function, they both do the same thing. So they're either both going to point up, and then there's going to be some gobbledygook in the middle, or they're both going to point down, and there's going to be some gobbledygook in the middle. So you can automatically make a prediction about what the end behavior of that graph is going to look like just by utilizing the odd and even function. So we're going to use this to our advantage as we start to predict end behavior patterns. Now the other cool thing about end behavior is that the leading coefficient actually tells us what the end on the right side, this is going to be the right side of the graph, it's going to tell us what the right side of the graph is going to do. And ultimately what that helps us discern is it helps us to figure out what both sides of the graph are going to look like. So if the leading coefficient is positive, the end of the graph, or the right side of the graph, is going to point upwards. So regardless of whether it's an odd or even function, if the leading coefficient is positive, the end of that graph is always going to point upwards. And then flipping that around, if you have a leading coefficient that is negative, the end, or the right side of the graph, is going to point downwards. So we're going to have some sort of graph that ends pointing downwards. So we're going to use these two slides of information to help us make some predictions about the end behavior of a graph. So for each of these two examples, we're going to use the degree and the leading coefficient to describe the beginning and end behavior of the graph. We're not going to really be able to give you details of the middle, but we're going to be able to describe the beginning and end behavior of that particular graph. Now, in order to do this, we do need to write this in standard form. So I'm going to write this in descending order here. So this should become negative 3x to the 4th plus 2x cubed plus 4x squared minus 4x. Now from here I can see that this is an even function because the highest power is 4. So this is an even function, which tells me that they're both sides of that graph, the beginning and the end, point in the same direction. Then from here I can also see that that leading coefficient is negative 3, and because it's negative, the right side of the graph is going to point downwards because it's a negative value. So if I draw a little coordinate plane here, what I can do is I can make some educated guesses about what this is going to look like. I know that the right side of this graph is going to point downwards because the leading coefficient is negative. And then I know that there's going to be some stuff in the middle, and that ultimately it's going to end up pointing downwards again because it's an even function, and the beginning of the function and the end of the function have to do the same thing. So while I understand that this middle portion here is not necessarily correct, I can make some very concrete claims about the beginning and the end behavior. So what I'm going to do from here is I'm going to talk about what happens as x approaches negative infinity and what happens as x approaches infinity. So as x approaches negative infinity, it means as x heads towards the super negative numbers. As x approaches negative infinity, the function, so your f of x value, is going, notice how it's pointing downward. So it's going to approach negative infinity as well. And then here I can say, well, as x approaches infinity this way, our function approaches negative infinity as well. So these are the claims I'm looking for you to make. I'm looking for you to make an educated guess about what is going to happen as x becomes really big one way and really big the other. And because of these patterns that we've noticed, we are able to say with confidence that as x goes towards positive or negative infinity, the f of x values or the y values are going to point downwards towards negative infinity in the y direction. So let's take a look at this second example here. Again, I need to make sure I rewrite this into standard form. So this should be 2x to the 5th plus 5x to the 3rd plus 3x. What I can see once I write it into standard form is that this is an odd function. So those ends are going to point in the opposite direction. And then I can also see that my leading coefficient is a positive 2, which means that the right side of the graph is going to point upwards. So again, I can make a little sketch here. And I can say, well, I know that the right side of the graph is going to point upwards. Then there's going to be some stuff that happens in here, and then the left side of the graph has to point the opposite direction, so it's going to point downwards. So we can see here that we have an odd function with one end pointing up and one end pointing down, and because it has a positive leading coefficient, the right side is the end that is pointing up. So now again, we're going to make some claims about what happens as x approaches negative infinity and as x approaches infinity. And what I notice here is that when x approaches negative infinity, the graph is going down. So our f of x values, or our y values, are going to go downwards towards negative infinity. And then I also notice that as x approaches infinity, the graph is going upwards, so our f of x values are going to approach positive infinity because they are going up forever. So what you should be able to do at this point is you should be able to look at a function and you should be able to describe what's going to happen in its beginning behavior, so on the left side of the graph, and what's going to happen on the right side of the graph just by utilizing even or odd function and leading coefficient.